So we're at a point in our astronomy unit where I want to take a minute to just have a little pause and talk about the 5 lessons that we have learned about so far and recap the information that we've learned in those previous 5 lessons. Now, in the first lesson, we learned all about our sun, and we learned that our sun is actually a star, and it's the only star in our solar system, and it is the very center of our solar system. All of the planets that we have in our solar system revolve around the sun. And we also learned why it's important. It provides light and heat to the earth for us. Without it, it would be a very, very cold place and no one would be able to live here. It also allows plants to grow. In other units in science, we've talked about how plants need light in order to grow. So without the sun, we would not have our plants growing. And without the plants growing, we wouldn't be able to survive because the animals that we eat for our meat need plants to eat and survive off of that. So without the plants that the animals eat, we wouldn't be able to have all of that meat and all of the plants that we eat now. So we wouldn't be able to have any food without the sun. And we also talked about how while it is important to make sure we're wearing sunscreen because some of the rays that come off the sun can be harmful to our skin, a lot of the rays that come off the sun also have vitamins that make our body healthy and allow our bodies to grow. So those vitamins are also very important that we get from the sun as well. In the next unit, we talked about why we have day and night. In the next lesson, we talked about why we have day and night. In the first photo on the bottom in the left-hand corner, we see an imaginary line that cuts through the North and the South Pole in the Earth, and that's called an axis, and it is a little bit tilted. Now, the Earth is continuously spinning around itself on that axis, so different parts of the Earth are facing the sun at different times. And that's the reason that we have our daytime and nighttime. It makes it look like the sun is rising and setting, but actually what's happening is the sun is staying still and the earth is moving around itself, spinning around itself. And it takes the earth about 24 hours or one day to complete one rotation around its axis. So the earth is continuously spinning around itself, and that's what gives us our daytime and our nighttime. In addition to that, the Earth is also moving around the sun while it's spinning, and that's called a revolution, and that's in the bottom right-hand corner. And the Earth takes about 365 days, or about 1 year, to complete one full revolution around the sun. And as the Earth is going around the sun, that's what causes us to have our seasons, our spring, our summer, our winter, and our fall seasons, as the Earth is going around the sun. So seasons happen when the earth goes around the sun, and our daytime and our nighttime happen as the earth is spinning around itself as different parts of the earth hit the sun at different times. In the next lesson, we were introduced more to stars, and we learned that stars are just big balls of gas. And what that means is, as opposed to liquids and solids, you can put your hand right through gas. Think of in the winter time when you go outside and you can see your breath because it's so cold and your breath is so warm, and you breathe out and you can see your breath. That's a gas, and that's what stars are made of. Stars, as we see them, they look pretty tiny in the sky, but they're actually huge. And most of the stars that we can see in the night sky are bigger than our sun. And if you remember, our sun can fit 1 million Earths inside of it. And most of the stars that we can see in the sky are bigger than our sun. So why do we see them so tiny in our sky? That's because they are very, very far away. Even if you got in our fastest rocket ship we have, it would take you thousands of years to reach the closest star to our galaxy. The reason that we can see them still is because they shine incredibly bright. Their light is super, super bright and is able to reach us all the way on Earth. And they're also very hot, but they still range in temperature. We call it a redshift and a blue shift. Stars, like a lot of things that we know of, do have a lifespan, and we can tell when a star is getting to a point where it's ready to cause a minor explosion, which won't affect us because they're so far away. But we can see when they're getting to the end of their lifespan based on what kind of redshift or blue shift they're in. And that's in the bottom left-hand corner. We see a redshift, blue shift star. In the right-hand corner, we can see all of those stars. While it doesn't look like there may be a lot of stars, there are millions and millions and millions of stars that are in the universe. While we only have the one star, our sun, in our solar system, there are so many other stars in the universe for us to see and for us to look at. We also learned about constellations. Constellations are groups of stars that can be connected with an imaginary line to create a sort of picture. Early people, before we had real maps and before we had real compasses and before we had the technological guidance systems that we know of today, they used these stars and these constellations as guidance systems. The first picture in the left-hand corner shows the Little Dipper. And we talked about how the Little Dipper on the very end has the North Star attached to it. The North Star is the only star in our northern hemisphere that pretty much stays the same. All of the other stars, it looks like they're rotating around that star, but again, the stars are staying in the same place as the Earth spins around its axis. That's why it looks like they're moving. But the North Star in the northern hemisphere is basically the only star that looks like it stays the same. So early people would use the North Star as a guidance system, whether they were hiking in the woods, whether they were trying to get to a new location, or if they were on a boat in the middle of the sea, they would follow that North Star so they knew that they were continuously going north so they wouldn't veer off their path. So early people used these constellations as guidance systems. They also used them for storytelling. We've talked a lot about ancient people and how storytelling was a huge part of their life. So constellations was another way for them to storytell, and it was another way for them to try to understand the universe and what was happening in it. The constellations in the bottom right-hand corner told a story. This is one of the stories that we talked about in this unit. Orion, right here, was a mighty hunter, and he boasted about how he was the best hunter and no one could defeat him. So the people told the story of Orion and told about how the gods were very upset that Orion would boast about being a great hunter. So the gods sent out Taurus, the bull, to try to defeat Orion. But Orion was never alone, as he had his two dog animal companions, Canis Minor and Canis Major, helping Orion fight the bull Taurus. And there's a lot of different stories like that, and people used these constellations to tell stories and try to gain an understanding of the universe and what was happening in the universe. And the last thing we talked about was moon phases. It looks like the moon is different sizes and different shapes in our sky, but again, the moon is a giant hunk of rock. It's not actually changing. It's not actually changing its shape and its size. It just appears like that. It just looks like that, and we call them phases. So just like the Earth, the moon also spins on an axis. So the same part of the moon is always facing the Earth. And just like the Earth revolves around the sun, the moon revolves around the Earth. So we can see in that very first bottom left-hand picture, the moon is going around the Earth, and it's constantly going around the Earth. And because it's going around the Earth, it's blocking out the sun at different portions as it's going around. And we can see that in the second picture in the right-hand corner. As the sun rays are coming in, the moon is blocking that part of the sun. Now, we talked about how the moon is not able to produce its own light. The reason why we see it shine so bright in the sky is because it's reflecting all of those sunlight and all of those sun rays. So depending on where the moon is, it's going to reflect at different parts, and that's where we can see all of those different shapes, and we call them moon phases. So we can see right here, where no light is getting through, we're not going to see a moon in the sky. It's still there, but we're not able to see any of the light that it's reflecting because it's not able to reflect anything. And that's what we call a new moon, when it looks like there's no moon in the sky. As we can see more and more of the moon, we call it waxing. More of the moon is able to be seen, and right here where it looks kind of like a banana, we call that a crescent moon. And when we can see more of it, we call that a waxing crescent moon. And then when half of the moon we are able to see, well, that's called a half moon. We can see half of the moon. It's a waxing half moon. We can see a full bright moon when it's a full moon. we can see the whole face of the moon reflecting the sunlight. That is a full moon. And then as it starts to disappear again, we call that waning. So again, this is another half moon. And because it looks like it's starting to disappear from the full moon, it's a waning half. And then we see another crescent moon, and it's a waning crescent because more of it is disappearing. And then it goes back to the new moon. So we see the crescent and the half moon twice. And that's why we have that waxing and waning term. So we can understand which part of the crescent and which part of the half moon that we're seeing. So we learn about 4 phases. We learn about the new moon when it looks like there's no moon in the sky. The crescent moon when it kind of looks like a banana in the sky. A half moon when we can see half of the face of the moon. And a full moon when it looks like we can see that full shining face of the moon. So that was all 5 of the lessons that we have learned about in this astronomy unit. If you need a refresher on any of these, please go back and do that now. You can either go back in this lesson and just pick up all of the different things that we've talked about and all the things that we've touched on in this lesson, or you can go back to the other lessons and listen to the full lesson or parts of those lessons from previous. When you're all done with that, please return to Seesaw and do the activity that goes along with all 5 of these lessons.